Imagine stepping outside on a seemingly ordinary day, only to witness something so bizarre that it defies everything you thought you knew about nature. Perhaps it's frogs falling from the sky, a swelling fire tornado consuming everything in its path, or snow blanketing the scorching sands of the Sahara Desert. These aren't scenes from a fantasy novel, they're real weather phenomena that have left scientists, historians, and ordinary people baffled. Welcome to the world of shocking weather events, where reality is stranger than fiction. Weather shapes our lives daily, but most of us rarely stop to think about how unpredictable and extraordinary it can be. Sure, we know about thunderstorms, hurricanes, and blizzards. But what about events so rare and unexplained that they've inspired legends, sparked scientific investigations, and even left behind unsolved mysteries? These are the stories that make us question the power and complexity of Earth's atmosphere. The events we're about to explore don't just make for fascinating stories, they also provide a window into the science of extreme weather. From the mechanics of rainstorms that drop fish instead of water to the role of climate change in driving once unimaginable phenomena, this journey will not only entertain but also educate. Whether you're a weather enthusiast, a skeptic, or simply someone who loves a good mystery, you're about to discover a side of nature that few ever see. Did you know that a single weather event can alter the course of history? In 1815, the eruption of Mount Tambora in Indonesia triggered what became known as the Year Without a Summer. This catastrophic event led to widespread crop failures, famine, and even inspired literary works like Mary Shelley's Frankenstein. Extreme weather isn't just a curiosity, it's a force that shapes human civilization, often in ways we don't fully understand. In this video, we'll delve into some of the strangest weather events ever recorded. We'll examine the science behind them, uncover the mysteries that remain unsolved, and explore the impact they've had on the world. From rain that isn't really rain to firestorms that behave like tornadoes, each event challenges what we think we know about our planet. Along the way, we'll provide data, case studies, and expert insights to help you understand how these phenomena occur, and why they're so rare. So, what makes these events so shocking? It's not just their rarity or their dramatic appearance. It's the way they force us to confront the unpredictable power of nature. They remind us that despite our advanced technology and scientific knowledge, the Earth still holds secrets that can astonish and humble us. And while some of these phenomena can be explained by science, others remain mysteries, fueling debate and wonder among experts and enthusiasts alike. As we begin our journey through the most shocking weather events ever recorded, think about the last time nature surprised you. Maybe it was an unexpected snowstorm, a brilliant double rainbow, or a thunderstorm that seemed to light up the entire sky. Whatever it was, consider this: what you're about to learn will redefine your understanding of what weather can do. It's time to explore the unbelievable, the unexplainable, and the utterly fascinating world of extreme weather phenomena. Let's get started. Unbelievable rain phenomena. Rain is an everyday phenomenon. Water falls, plants grow, and life goes on. But what if the rain wasn't water at all? In 2005, residents of a small Serbian town were left baffled when frogs started raining down during a thunderstorm. They watched as these tiny amphibians leaped across rooftops and roads, seemingly dropped straight from the heavens. Similarly, in the remote town of Oro, Honduras, an annual event known as the Lluvia de Peces, or Rain of Fish, has been occurring for over a century. Each year, during the rainy season, locals find live fish scattered across the streets after heavy downpours. The scientific explanation points to waterspouts, tornado-like systems that form over water. These vortexes are powerful enough to suck aquatic creatures from rivers, lakes, or seas and carry them high into the atmosphere. As the storm moves inland, the animals are deposited back to Earth, often miles from their original location. However, not all cases of animal rain can be neatly explained by meteorology. In some instances, the animals appear unscathed by the journey, leaving experts scratching their heads. While these rains might seem quirky, they often hold significant cultural value. In Oro, for example, the Rain of Fish is seen as a blessing and tied to local legends about a Catholic priest who prayed for food for the hungry. This blending of natural phenomenon and folklore makes events like these more than just weather. They're deeply woven into the fabric of human storytelling. Rain of animals, a phenomenon of nature's mysteries. Rain is something we experience regularly, but what if the raindrops turned into animals? While it sounds like something out of a science fiction movie, the phenomenon of animals raining from the sky has been documented throughout history and continues to mystify scientists. Two of the most well-known instances are the rain of frogs in Serbia in 2005 and the annual Lluvia de Peces, or Rain of Fish, in Honduras, both of which have baffled locals and experts alike. In 2005, residents of a small Serbian town were startled to see frogs falling from the sky during a thunderstorm. Reports described thousands of frogs scattered across the streets, leaping and hopping as if they had appeared out of nowhere. The event captured global attention, and while theories abounded, the most plausible explanation was tied to waterspouts. These powerful tornado-like systems form over water, creating a vortex that can suck lightweight objects, including small animals, high into the air. As the storm loses energy and the vortex dissipates, the animals are released, often miles from their original location. However, what made the Serbian frog rain even more puzzling was the sheer number of frogs involved and their apparent unharmed state upon landing. The phenomenon isn't limited to frogs. In the small Honduran town of Oro, the Rain of Fish has been occurring for over a century and is so common that locals have turned it into an annual tradition. During the rainy season, heavy storms sweep through the area, and once the downpour subsides, locals find live fish scattered across the ground. Interestingly, these fish are not species typically found in nearby rivers or lakes, adding to the mystery. The Lluvia de Peces is celebrated as a miraculous event, often attributed to a 19th century priest who prayed for food during a famine. For the people of Oro, the fish rain isn't just a weather event, it's a spiritual blessing. From a scientific perspective, waterspouts and tornadic activity remain the leading explanations for animal rain phenomena. Waterspouts form when warm air rises rapidly over water, creating a rotating column of air that can lift objects such as fish, frogs, and even small crustaceans. Once these objects are carried into the atmosphere, they travel with the storm, sometimes being transported for miles before being released. Tornadic activity, which involves stronger and more widespread atmospheric instability, may also play a role in these events, especially in areas with severe storms. However, not all aspects of animal rain can be neatly explained by meteorology. Questions linger about how these creatures survive such a tumultuous journey and why these occurrences are so rare. While science provides plausible theories, the phenomenon continues to capture the imagination, blending natural wonder with cultural storytelling. Whether you see it as an atmospheric anomaly or a divine miracle, rain of animals remains one of the most extraordinary weather events ever recorded. Blood rain, a crimson mystery. Historical accounts of blood rain in Europe. Throughout history, the phenomenon of blood rain has both terrified and fascinated people. In medieval Europe, accounts of crimson-hued rainstorms filled chronicles and sparked fear among communities. These rains were often seen as omens of war, disease, or divine punishment. For instance, in 582 AD, a Roman historian recorded a rainstorm that left fields stained red, a sight interpreted by many as a harbinger of doom. Similar reports emerged during the 8th century in Spain, where red rainstorms were documented as warnings from the heavens of impending disaster. Without the scientific knowledge we have today, such events were woven into cultural and religious narratives. Priests and leaders often linked blood rain to wrathful deities or supernatural forces. These interpretations fueled superstitions and led to rituals meant to appease the gods or ward off misfortune. Even as late as the 19th century, accounts of blood rain in England and France were accompanied by widespread panic, with people believing that divine judgment was at hand. The modern mystery of Kerala's red rain. Fast forward to modern times, and the mystery of blood rain has not entirely disappeared. One of the most intriguing cases occurred in Kerala, India, in 2001. For nearly 2 months, sporadic rain showers left the region's landscape coated in red droplets. Streets, rooftops, and even clothes left outside were stained with what looked like blood. The phenomenon was so striking that it garnered international attention, with scientists and media alike scrambling to uncover its cause. Initial explanations suggested that the red rain was the result of desert dust from the Arabian Peninsula, carried over by monsoon winds. However, as researchers analyzed the rainwater, they discovered microscopic particles that were biological in origin. These particles were later identified as spores from a specific type of red algae. This discovery provided a plausible explanation. During the monsoon season, atmospheric turbulence may have lifted these spores from nearby forests or water bodies, mixing them into the rain clouds. However, the mystery didn't end there. Some researchers proposed far more controversial theories, including the idea that the spores were of extraterrestrial origin. This hypothesis gained traction when further studies revealed unusual properties in the spores, such as their resilience to extreme conditions. While most scientists dismissed this theory as speculative, it captured public imagination and added another layer of intrigue to the Kerala blood rain. Controversial theories and scientific findings records. While the case in Kerala has a largely accepted scientific explanation, blood rain continues to evoke debate and curiosity. In Europe, similar events have been explained as the result of airborne particles like desert sand, pollen, or volcanic ash. These materials, when suspended in rain clouds, can alter the color of rainwater, giving it a red or brownish hue. For example, the Sahara Desert's fine dust has been known to travel as far as southern Europe, creating rainstorms with reddish tints. Despite these advancements in understanding, the cultural and emotional impact of blood rain remains profound. Whether as an ancient omen or a modern scientific puzzle, it continues to remind us of nature's ability to surprise and bewilder. The sight of crimson rain falling from the sky is not easily forgotten, blending science, history, and mystery into one unforgettable phenomenon. Other strange rains, when the sky delivers the unexpected jelly rain, Scotland's slime mystery. In 2009, residents of a small Scottish town experienced one of the most bizarre weather phenomena ever recorded: jelly rain. Following a heavy storm, locals discovered strange, translucent, jelly-like blobs scattered across fields and gardens. The slimy material appeared without explanation, and witnesses described it as otherworldly, with no discernible smell or immediate link to any known substance. The phenomenon quickly attracted media attention, and scientists were called in to investigate the mysterious blobs. One theory suggested that the blobs were remnants of frog spawn, lifted into the atmosphere by strong winds and deposited back to Earth. This explanation aligns with known cases where waterspouts or tornado-like systems have transported aquatic organisms and dropped them far from their original locations. However, critics of this theory noted the absence of frog eggs or embryos within the jelly, leaving the cause uncertain. Another possibility was that the jelly originated from a type of star jelly, a substance historically linked to meteor showers. Star jelly has been referenced in folklore for centuries, often described as a gelatinous material that appears on the ground after meteor sightings. Modern scientists, however, lean towards biological explanations, such as the discharge from amphibians or decaying organic matter, rather than extraterrestrial origins. Yet, despite these hypotheses, no definitive source of Scotland's jelly rain has been identified. This strange occurrence remains one of nature's unsolved puzzles, sparking curiosity about the complex interactions between weather systems and the environment. Whether it's frog spawn, decomposed organic matter, or something entirely unexplored, jelly rain serves as a reminder of how little we truly understand about the forces shaping our atmosphere. Money rain, a fortune from the heavens. Not all rainfalls leave people bewildered. In some cases, they leave them delighted. In 2007, a small German town witnessed what can only be described as a financial windfall. Banknotes rained from the sky. Stunned residents watched as thousands of euros fluttered down during a sudden gust of wind, turning an otherwise ordinary day into an unforgettable event. The surreal sight of money falling from the heavens led to a flurry of excitement, with people rushing to collect the cash. While investigations later revealed that the money had been thrown into the air by individuals attempting to hide stolen cash, the incident captured global attention and became a viral sensation. Despite its human origins, this money rain demonstrated the unpredictability of what the skies can deliver. Another example occurred in Kuwait in 2015, when locals reported a similar event involving paper currency falling during a windy day. While likely tied to accidental or deliberate human actions, these occurrences blur the line between natural phenomena and human intervention, adding an almost whimsical element to the list of strange rains. The enduring fascination with unusual rain, whether it's mysterious jelly or unexpected wealth, strange rains continue to captivate our imagination. These phenomena remind us that nature, and sometimes human activity, has a way of delivering surprises when we least expect them. From the eerie to the delightful, these events challenge our understanding of what's possible, making every storm a potential story worth telling. Temperature extremes and unexpected weather. The heat waves, nature's scorching wrath. Heat waves are among the most devastating weather phenomena, often arriving unannounced and leaving a trail of destruction in their wake. These prolonged periods of extreme heat can disrupt ecosystems, strain infrastructure, and pose serious health risks. One of the most infamous examples in modern history is the European heatwave of 2003, an event that stunned the world with its severity and tragic consequences. The European heatwave of 2003, a tragic milestone. In the summer of 2003, Europe experienced a heatwave that shattered records and pushed temperatures to unprecedented levels. Countries like France, Spain, and Italy bore the brunt of the crisis, with temperatures soaring above 40 degrees Celsius (104 degrees Fahrenheit) in many regions. The heatwave, which persisted from June to August, was particularly lethal due to its duration and intensity. Over 70,000 people lost their lives, making it one of the deadliest natural disasters in European history. The elderly were particularly vulnerable, with many succumbing to heat stroke, dehydration, and other heat-related illnesses. Urban areas faced additional challenges, as the dense infrastructure trapped heat, creating heat islands that amplified temperatures even further. Hospitals became overwhelmed, morgues reached capacity, and power grids were pushed to their limits as air conditioning usage soared. Agriculture and ecosystems also suffered immensely. Crops withered in the fields, water supplies dwindled, and wildfires raged across drought-stricken areas. The economic toll of the heatwave was staggering, with losses estimated at over €13 billion. In the aftermath, governments across Europe pledged to implement better heatwave preparedness measures, including early warning systems and public health campaigns. Urbanization and the heat island effect. One of the key factors that exacerbated the impact of the 2003 heatwave was the urban heat island effect, a phenomenon where cities experience significantly higher temperatures than their surrounding rural areas. This occurs because urban surfaces, such as asphalt, concrete, and buildings, absorb and retain more heat than natural landscapes. During the day, these materials soak up solar radiation, and at night, they release it slowly, preventing cities from cooling down effectively. Urbanization has intensified this effect, as green spaces are replaced with heat-absorbing infrastructure. The result is a microclimate within cities that can be several degrees warmer than surrounding areas. During heatwaves, this difference becomes even more pronounced, compounding the health risks for urban populations. Efforts to mitigate the heat island effect include increasing urban greenery through parks, rooftop gardens, and tree-lined streets. These measures help cool cities by providing shade and enhancing evapotranspiration. Additionally, reflective roofing materials and lighter colored surfaces can reduce heat absorption, making urban environments more resilient to extreme temperatures. A warning for the future. The 2003 European heatwave serves as a stark reminder of the dangers posed by rising global temperatures. As climate change continues to drive more frequent and severe heatwaves, understanding and addressing factors like the heat island effect will be crucial. Preparing for these events isn't just a matter of urban planning, it's a matter of life and death. The lessons of 2003 should galvanize efforts to build more sustainable and heat-resilient cities, ensuring that the next heat wave doesn't become another tragic milestone in history. Cold in unexpected places, snow in the Sahara Desert. The Sahara's icy surprise. The Sahara Desert is synonymous with searing heat, endless sand dunes, and blistering sun. As the largest hot desert in the world, spanning 9.2 million square kilometers across North Africa, it's a place where temperatures can soar above 50 degrees Celsius, 122 degrees Fahrenheit, during the day. Snowfall is the last thing anyone would expect in this arid expanse, yet it has happened, most notably in 2018 and 2021. These rare and extraordinary events captivated the world, turning the red sands of the Sahara into a surreal winter wonderland. Snowfall in 2018, a stunning spectacle. In January 2018, residents of An Sefra, a small Algerian town nestled on the northern edge of the Sahara, woke up to an astonishing sight: the desert sands blanketed with snow. Dubbed the gateway to the desert, An Sefra had only experienced snow a handful of times in its history, making the 2018 event a momentous occasion. Temperatures plummeted overnight, and snowflakes began to fall, coating the dunes with a layer of white that lasted for several hours before melting under the sun. The images of snow-covered dunes quickly went viral, with people around the globe marveling at the juxtaposition of the desert's fiery orange sands and the icy white snow. It was a reminder of nature's unpredictability and its ability to surprise even in the most unlikely places. Snow returns in 2021, a second act. In January 2021, snow once again graced the Sahara, this time accompanied by freezing temperatures that dipped as low as 3 degrees Celsius, 27 degrees Fahrenheit. An Sefra found itself at the center of another rare weather phenomenon as snow and ice covered the region. The event was even more dramatic than the one in 2018, with thicker snow accumulations creating patterns of white streaks across the dunes. The 2021 snowfall reinforced the notion that while exceedingly rare, such events are not entirely impossible in the Sahara. Meteorologists and climate scientists delved into the conditions that allowed for these unusual occurrences, shedding light on the complex interplay of atmospheric forces at work. Why snow in the Sahara is so rare? Snowfall in the Sahara is an extraordinary event because the desert's climate is predominantly hot and dry, characterized by minimal precipitation and extreme temperatures. For snow to occur, a unique combination of factors must align. The primary driver of these rare snow events is cold air masses originating from Europe. During winter, powerful Arctic cold fronts occasionally push southward, bringing frigid air into North Africa. When these cold air masses interact with moist air in the region, conditions become ripe for snowfall. However, moisture is scarce in the desert, making such interactions exceedingly uncommon. And Sahara's elevation also plays a role. Situated at an altitude of approximately 1,000 meters, 3,280 feet, above sea level, the town is cooler than lower-lying areas of the Sahara, increasing the likelihood of snow during rare cold snaps. Still, these conditions are fleeting, and the desert's intense daytime heat ensures that any snow melts quickly. A rare glimpse of nature's contrast. Snow in the Sahara is a striking reminder of the planet's dynamic and interconnected weather systems. It demonstrates how even the most extreme environments can occasionally defy expectations, producing moments of stunning beauty that capture the world's attention. These events may be fleeting, but their impact lingers, reminding us of the delicate balance that governs Earth's climate and the surprises it still holds in store. Sudden temperature swings. The remarkable case of Montana. A record-breaking temperature change in Montana. Montana, known for its rugged landscapes and wild weather patterns, holds the record for one of the most dramatic temperature swings ever documented. On January 15, 1972, the town of Loma, Montana, experienced a jaw-dropping shift in temperature that stunned meteorologists and locals alike. Within a single 24-hour period, the temperature soared from a frigid 54 degrees Fahrenheit, 48 degrees Celsius, to a relatively balmy 49 degrees Fahrenheit, 9 degrees Celsius, a staggering change of 103 degrees Fahrenheit, 57 degrees Celsius. The rapid warming created surreal scenes, with ice and snow melting at unprecedented speeds. Residents who had bundled up in heavy winter gear found themselves shedding layers as the landscape transformed before their eyes. The event made headlines across the United States, cementing Montana's place in weather history as a state of extremes. Chinook winds, nature's rapid heating mechanism, and the key driver behind Montana's extraordinary temperature swings is the Chinook wind, a meteorological phenomenon unique to regions near mountainous terrain. Named after the Chinook people of the Pacific Northwest, these winds are often referred to as snow eaters due to their ability to rapidly melt snow. Chinook winds occur when moist air from the Pacific Ocean is forced upward by mountain ranges, such as the Rockies. As the air ascends, it cools and loses moisture, often leading to precipitation on the windward side of the mountains. Once the air reaches the summit and descends the leeward side, it undergoes compression and warms rapidly. This process, known as adiabatic heating, can cause temperatures to rise dramatically in a matter of hours or even minutes. In Montana, the interplay between cold Arctic air and the arrival of warm Chinook winds creates ideal conditions for sudden and extreme temperature shifts. The Arctic air, heavy and dense, sits low to the ground until it is displaced by the lighter, warmer Chinook winds. This interaction can lead to astonishingly fast changes in local temperatures, as seen in the 1972 event. The impact of Chinook winds on daily life. While Chinook winds can bring relief from harsh winter conditions, they also pose challenges. The rapid melting of snow can lead to localized flooding, while the sudden warmth can cause icy roads to become dangerously slick. For residents in Montana and other regions affected by Chinook winds, these shifts require constant vigilance and adaptability. Livestock and wildlife are also significantly impacted. For animals accustomed to enduring bitter cold, Abrupt temperature changes can disrupt feeding patterns and energy conservation. Additionally, the sudden melting of snow can expose grazing areas, providing temporary relief for animals but potentially leading to longer-term water management issues. The science and wonder of sudden temperature swings. The temperature swings experienced in Montana highlight the incredible complexity of Earth's weather systems. Chinook winds, while scientifically explainable, feel almost magical in their ability to transform a frozen landscape into a spring-like environment within hours. These events serve as a reminder of how interconnected atmospheric forces are, demonstrating how mountain ranges, air pressure, and wind patterns work together to create phenomena that are as awe-inspiring as they are extreme. Sudden temperature swings may be rare, but their dramatic effects are unforgettable. Whether you're in Montana or any other Chinook-prone region, witnessing such an event is a testament to the unpredictable and extraordinary power of nature. Fire and lightning phenomena. Nature's fiery fury. Fire tornadoes, a rare and devastating spectacle. When you think of tornadoes, images of swirling winds tearing through landscapes may come to mind. But what if those winds carried fire instead of rain? Fire tornadoes, or fire whirls, are among the most extraordinary and terrifying phenomena in nature. Combining the destructive power of tornadoes with the intense heat of wildfires, these events are as rare as they are devastating. One of the most infamous examples occurred during California's Carr Fire in 2018, leaving a trail of destruction and a deep fascination with the science behind these fiery storms. The Carr fire tornado, a monster in the flames. In July 2018, the Carr Fire near Redding, California, raged across thousands of acres, fueled by dry vegetation, high temperatures, and strong winds. Amid the chaos, a fire tornado of unprecedented scale emerged, shocking even seasoned wildfire experts. The inferno reached speeds of up to 143 miles per hour, 230 kilometers per hour, rivaling the intensity of an F3 tornado, and temperatures within the vortex soared to a staggering 2,700 degrees Fahrenheit, 1,500 degrees Celsius. This fire tornado destroyed homes, uprooted trees, and tragically claimed lives, becoming one of the most destructive and intense fire whirls ever recorded. Eyewitnesses described the fire tornado as a towering column of flames, ash, and debris spiraling violently into the sky. Its formation was so unique that meteorologists and firefighters studied it extensively to better understand the conditions that allowed such an extreme event to occur. The Carr fire tornado became a chilling reminder of how unpredictable and dangerous wildfires can become when weather elements align. How fire tornadoes form. A recipe for chaos. Fire tornadoes form when intense heat from a wildfire generates a powerful updraft of hot air. As this hot air rises rapidly, it begins to rotate, often influenced by existing wind patterns or turbulent air currents. The swirling motion draws in more oxygen, feeding the fire and intensifying the flames. When these conditions are combined with strong horizontal winds, the fire can spiral into a full-fledged tornado-like vortex. The role of wind patterns is critical in the creation of fire tornadoes. During the Carr Fire, a combination of strong surface winds and shifting atmospheric pressure created a perfect storm for a fire whirl. These winds acted like a spinning top, giving the updraft its rotation. Additionally, Dry fuels and the region's hilly terrain added to the complexity, funneling heat and air currents into a confined area, which intensified the vortex. Another key factor is the presence of pyrocumulus clouds, thunderclouds formed by intense heat from a wildfire. These clouds can create their own weather systems, generating strong downdrafts and erratic winds that exacerbate fire behavior. In the case of the Car fire, such interactions likely contributed to the extreme size and intensity of the fire tornado. The impact of fire tornadoes. Fire tornadoes pose a unique and severe threat, as they are unpredictable and nearly impossible to control. Their intense heat can ignite anything in their path, and their winds can carry burning debris far beyond the fire's main perimeter, spreading the flames rapidly. For firefighters, encountering a fire tornado is a worst-case scenario, as traditional suppression tactics are ineffective against such ferocious energy. The Car fire tornado highlighted the growing risks posed by wildfires in a warming climate. As temperatures rise and droughts become more common, the frequency and intensity of wildfires, and the potential for fire tornadoes, may increase. Understanding these phenomena is crucial for improving firefighting strategies and predicting where and when they might occur. Awe-inspiring yet deadly fire tornadoes are a stark reminder of nature's destructive power and the complex interplay of fire and weather. While they may inspire awe with their raw energy and dramatic appearance, they leave devastation in their wake, transforming landscapes and lives in a matter of moments. The Car fire tornado stands as a haunting example of what can happen when fire and wind combine, serving as both a warning and a call to action in the face of increasingly extreme weather events. Ball lightning, nature's elusive light show. What is ball lightning? Ball lightning is one of the most mysterious and mesmerizing phenomena ever reported during thunderstorms. Unlike traditional lightning, which manifests as a quick, jagged flash of light, ball lightning appears as glowing orbs that seem to hover or drift through the air. These luminous spheres, ranging in size from a golf ball to several feet in diameter, have been described as silent, hissing, or even exploding, leaving witnesses awestruck and puzzled. First documented centuries ago, ball lightning has been the subject of folklore, scientific inquiry, and even skepticism. The phenomenon remains so rare and unpredictable that scientists have struggled to observe it under controlled conditions, leaving much of its true nature shrouded in mystery. Eyewitness accounts, glowing orbs in the storm. Eyewitness reports of ball lightning span the globe, often occurring during or immediately after thunderstorms. One of the most famous accounts comes from 19th century Russia, where ball lightning reportedly floated through a church, terrifying parishioners before vanishing without a trace. In another case, during World War II, pilots described encountering luminous orbs that seemed to follow their aircraft, earning the nickname Foo Fighters. Modern reports include a 1984 incident in the United States, where a man described seeing a glowing orb float across his yard during a thunderstorm, emitting a faint crackling sound before dissipating. Similar accounts mention orbs entering homes through open windows, floating near people without causing harm, and sometimes vanishing in a small explosion or puff of smoke. These reports often share common characteristics. The orbs appear during stormy weather, they seem to hover or move unpredictably, and they disappear within seconds or minutes. However, variations in color, size, and behavior add to the enigma, making ball lightning a challenging phenomenon to study scientifically. Theories and explanations, plasma, physics, and illusions. Over the years, scientists have proposed numerous theories to explain ball lightning, ranging from plasma physics to optical illusions. One leading hypothesis suggests that ball lightning is a form of plasma, an electrically charged state of matter. According to this theory, ball lightning forms when lightning strikes certain surfaces, such as silicon-rich soil, vaporizing material that becomes electrically charged and forms a glowing sphere. This plasma sphere could then persist briefly, powered by the energy of the storm. Another theory ties ball lightning to microwave radiation. In this model, microwave energy generated during a lightning strike could create a contained plasma bubble, which would emit the glowing light observed in many sightings. This explanation aligns with laboratory experiments that have successfully created glowing orbs resembling ball lightning using microwave radiation. Skeptics, however, suggest that ball lightning may be an optical illusion or a misinterpretation of natural phenomena. For instance, after images caused by staring at a bright lightning flash could create the appearance of glowing orbs. Alternatively, the phenomenon might be a result of piezoelectric effects, where certain rocks under stress during a storm produce light. An enigma that endures despite advances in science and technology, ball lightning remains one of nature's most elusive mysteries. Rare and fleeting, it defies easy explanation and continues to spark debate among scientists and awe among those who witness it. Whether it's a plasma phenomenon, a product of the mind, or something entirely unknown, ball lightning reminds us that even in the age of modern science, the natural world still holds secrets waiting to be uncovered. St. Elmo's Fire, a beacon of superstition and science. Historical sightings by sailors, a glowing guide on the high sea street. Elmo's Fire has captivated the imaginations of sailors and explorers for centuries. Often described as a mysterious, glowing light that appears at the tips of ship masts or spars during thunderstorms, this phenomenon was both feared and revered. To ancient mariners, the ethereal blue or violet glow was thought to be a sign of divine intervention or protection. Many sailors believed it to be a blessing from Saint Erasmus of Formia, also known as Saint Elmo, the patron saint of sailors, hence the name. Historical accounts of Saint Elmo's Fire are woven into the lore of the sea. During dangerous storms, when lightning illuminated the skies and turbulent seas threatened to capsize ships, the appearance of these glowing lights brought hope and reassurance. Sailors interpreted the phenomenon as a sign that their patron saint was watching over them, guiding them through the tempest. Ancient texts from the Mediterranean, as well as writings by explorers like Christopher Columbus, recount sightings of the glowing fire, often described with a mix of awe and reverence. Even in literature, St. Elmo's Fire has been immortalized. In Samuel Taylor Coleridge's The Rime of the Ancient Mariner, it is referenced as a spectral light, emphasizing its mystical and supernatural allure. For centuries, this glowing phenomenon stood as a symbol of the bond between sailors and the mysterious forces of nature they encountered at sea. The science behind the glow: electrical discharge in action. While Street Elmo's fire may have seemed otherworldly to ancient observers, modern science has uncovered its natural explanation. St. Elmo's fire is a type of electrical discharge that occurs when the atmosphere becomes highly charged during thunderstorms. It is most commonly observed around pointed objects, such as ship masts, airplane wingtips, or even church steeples. The phenomenon occurs due to the ionization of air. When a thunderstorm generates an intense electric field, it can cause the air molecules near a sharp or pointed object to ionize, releasing a faint, glowing plasma. The sharpness of the object plays a crucial role because it amplifies the electric field at its tip, creating conditions ideal for ionization. This glowing plasma is what sailors and others have long referred to as St. Elmo's fire. The distinctive blue or violet hue is a result of nitrogen and oxygen in the atmosphere becoming electrically excited. As these gases return to their normal state, they emit light, creating the eerie glow associated with the phenomenon. While St. Elmo's fire is not dangerous itself, its appearance often coincides with severe thunderstorms, making it a natural indicator of potential lightning or turbulent weather. From superstition to science. Street Elmo's fire is a perfect example of how science can demystify natural phenomena that once inspired fear and wonder. What sailors once saw as a divine sign is now understood as a fascinating interplay of electricity and atmospheric conditions. Yet, despite its scientific explanation, the phenomenon retains its mystical charm. Its ghostly glow continues to captivate those lucky enough to witness it, serving as a reminder of the beauty and power of the natural world. Whether seen as a beacon of hope or an atmospheric marvel, St. Elmo's fire endures as one of nature's most enchanting spectacles. Rare atmospheric phenomena, auroras in unusual locations, auroras beyond their traditional borders. Auroras, known as the northern and southern lights, are typically confined to polar regions, where they paint the night sky with vibrant shades of green, red, and purple. These natural light shows are caused by charged particles from the sun interacting with Earth's magnetic field and atmosphere. But what happens when auroras defy expectations and appear far from the usual habitats? On rare occasions, auroras have been witnessed closer to the equator, stunning observers and sparking questions about how and why these breathtaking displays occur outside the typical boundaries. One notable instance occurred in September 1859, during the Carrington Event, the largest recorded solar storm in history. The auroras generated by this massive geomagnetic disturbance were so powerful that they were visible as far south as the Caribbean. Reports from the time describe red and green lights dancing across the sky in regions where such phenomena had never been seen. More recently, in October 2003, a solar storm known as the Halloween storm brought auroras to latitudes as low as Texas and Florida in the United States, captivating millions who had never before witnessed the phenomenon. These events demonstrate that under certain conditions, auroras can extend far beyond the usual polar confines, providing rare and unforgettable experiences for those lucky enough to witness them. The role of solar storms in expanding auroral regions. The key driver behind auroras appearing in unusual locations is solar storms. These storms are caused by eruptions on the sun's surface, known as solar flares or coronal mass ejections, CMEs, which release massive amounts of charged particles into space. When these particles reach Earth, they interact with the planet's magnetosphere, creating geomagnetic storms. During particularly strong geomagnetic storms, the Earth's magnetic field becomes highly disturbed, allowing the charged particles to penetrate deeper into the atmosphere and spread further from the poles. This phenomenon shifts the auroral oval, the region where auroras typically occur, closer to the equator. The result is auroras appearing in places that would otherwise never experience these luminous displays. The intensity of these events is measured by the KP index, a scale from 0 to 9 that indicates geomagnetic activity. During mild geomagnetic storms, the auroral oval remains near the poles, visible only in high-latitude regions. However, during extreme storms, the KP index rises to 8 or 9, significantly expanding the range of visible auroras. Auroras as harbingers of solar activity. While auroras in unusual locations are visually stunning, they also serve as a reminder of the sun's immense power and its influence on Earth. These events are often accompanied by disruptions to satellite communications, GPS systems, and even power grids. The Carrington event, for example, caused widespread telegraph failures and sparked fires in telegraph offices. Modern society, heavily reliant on technology, faces even greater risks during such solar storms, making the study of auroras and solar activity critical for understanding and mitigating these impacts. A rare and beautiful surprise. Auroras in unexpected locations are a testament to the dynamic relationship between Earth and the Sun. For those who witness these rare displays, the experience is unforgettable, a dazzling show of nature's raw power and beauty. They remind us that even phenomena we think we understand, like the Northern Lights, can still surprise us in extraordinary ways. Whether viewed from the Arctic or the equator, auroras continue to inspire awe and wonder, connecting people across the globe to the mysteries of the cosmos. Polar vortex outbreaks, unleashing the Arctic chill. What is the polar vortex? The polar vortex is a massive area of low pressure and cold air that resides in the polar regions, circling the North and South poles. It is held in place by a strong jet stream that acts as a barrier, keeping frigid Arctic air confined to its usual domain. However, when the polar vortex weakens or becomes displaced, it can spill icy air southward, bringing unusually cold conditions to regions unaccustomed to such frigid temperatures. Over the past decade, the United States has experienced several extreme cold events linked to polar vortex outbreaks, sparking both curiosity and concern. Polar vortex displacement and unusually cold winters in the U.S. One of the most notable polar vortex disruptions occurred during the winter of 2014, plunging much of the United States into a deep freeze. States in the Midwest and Northeast experienced record-breaking low temperatures, with cities like Chicago seeing wind chills as low as 50 degrees Fahrenheit, 45 degrees Celsius. This event was characterized by a massive southward displacement of the polar vortex, allowing Arctic air to flow unimpeded across the continental U.S. The effects were devastating, with widespread power outages, transportation disruptions, and billions of dollars in economic losses. Similar polar vortex events have been recorded in subsequent years, such as the 2021 cold snap that caused catastrophic power grid failures in Texas. Temperatures dropped well below freezing, a rarity for the region, leading to extensive damage to homes, businesses, and infrastructure. The displacement of the polar vortex in these instances highlights its ability to bring Arctic conditions to areas unprepared for such extremes. The role of climate change in polar vortex outbreaks. While polar vortex outbreaks are not new, scientists are increasingly examining the role of climate change in their frequency and intensity. One prevailing theory suggests that rising global temperatures are disrupting the stability of the polar vortex. As the Arctic warms at a rate nearly twice that of the global average, a phenomenon known as Arctic amplification, the temperature contrast between the polar region and mid-latitudes decreases. This weaker temperature gradient can cause the jet stream to become wavier, leading to polar vortex disruptions. These disruptions allow cold Arctic air to escape southward, creating conditions for extreme cold events. At the same time, regions in the Arctic may experience unusually warm weather as cold air is displaced elsewhere. This complex relationship between a warming planet and polar vortex behavior underscores the interconnectedness of Earth's climate systems. Preparing for future outbreaks. Polar vortex outbreaks are a stark reminder of the unpredictability of weather in a changing climate. Their impacts are not just limited to extreme cold but also include infrastructure failures, agricultural losses, and public health risks. Preparing for these events requires investment in resilient infrastructure, better forecasting models, and public awareness campaigns to ensure communities are equipped to handle sudden temperature extremes. The paradox of a warming world. The seemingly contradictory link between global warming and colder winters illustrates the complexity of climate science. While the overall trend is toward a warmer planet, the effects of this warming can manifest in surprising and severe ways. Polar vortex outbreaks serve as a reminder that climate change isn't just about rising temperatures, it's about increased variability and more frequent extremes. As we adapt to a changing climate, understanding and addressing phenomena like polar vortex disruptions will be crucial to building a more resilient future. Halo and sundogs, the sky's mystical display. The science behind halos and sundogs. Halos and sundogs are mesmerizing optical phenomena that appear in the sky under specific atmospheric conditions, captivating observers with their otherworldly beauty. Halos are circular rings of light that encircle the sun or moon, while sundogs, also known as parhelia, are bright spots that appear on either side of the sun. Both phenomena are caused by the interaction of sunlight or moonlight with ice crystals in the atmosphere. These ice crystals, often found in high-altitude cirrus or cirrostratus clouds, act as tiny prisms and mirrors. When light passes through these hexagonal crystals, it refracts and bends, creating the appearance of glowing rings or bright spots. The shape and orientation of the crystals determine the specific type of halo or sundog observed. Halos typically form at a 22-degree angle from the light source, creating the iconic circular ring, while sundogs appear horizontally on either side of the sun, often glowing with a rainbow-like tint. Sundogs are most commonly seen when the sun is low on the horizon, such as during sunrise or sunset, because the angle of the sunlight enhances their visibility. Similarly, halos are often observed during cold weather, particularly in regions where ice crystal-laden clouds are prevalent. A glimpse into cultural interpretations. Throughout history, halos and sundogs have been interpreted as celestial omens, symbols of divine power, or warnings of impending change. Ancient civilizations and medieval societies often attributed mystical or religious significance to these atmospheric wonders, weaving them into their myths, legends, and folklore. In ancient Rome, halos around the sun or moon were seen as signs from the gods, often believed to predict significant events such as wars, natural disasters, or the deaths of rulers. Similarly, in medieval Europe, sundogs were viewed with a mix of awe and fear. During battles or political upheavals, these bright celestial lights were interpreted as divine messages, guiding or warning leaders. One of the most famous historical accounts involving sundogs occurred in Sweden in 1535, when 3 suns were reportedly seen in the sky. This phenomenon, documented in both texts and paintings, became known as the sundog prophecy. The event was widely believed to foretell the rise of King Gustav Vasa and his consolidation of power in Sweden, blending natural observation with political symbolism. In Native American cultures, halos and sundogs were often seen as spiritual signs, representing the cyclical nature of life or serving as guides during important decisions. For Arctic indigenous peoples, who frequently encounter these phenomena due to their cold climate, halos were woven into stories about the sun and moon's relationship with the earth. Awe and wonder in modern times. Today, halos and sundogs are celebrated as stunning natural phenomena that connect science and beauty. While we now understand the physics behind these displays, their ethereal appearance continues to inspire wonder and creativity. Photographers and skywatchers eagerly capture these moments, sharing their beauty with the world and reminding us of the intricate interplay between light and atmosphere. Whether as a scientific curiosity or a cultural symbol, halos and sundogs remind us of the ever-changing and awe-inspiring nature of our skies. They are a testament to the power of light and ice to transform the ordinary into the extraordinary, offering glimpses into both the physical world and the stories humanity has woven around it for centuries. Destructive and unusual storms. Nature's unyielding power. Storms have always been a dramatic and often devastating display of nature's power. From hurricanes unleashing torrential rains to dust storms blanketing entire regions, these events not only leave physical destruction in their wake but also shape the lives and futures of communities. This section delves into 3 of the most destructive and unusual storms in history: Hurricane Harvey, the Dust Bowl storms of the 1930s, and Cyclone Idai. Each of these events stands as a testament to the extreme forces of nature and the long-lasting impact of such weather phenomena. Hurricane Harvey's record rainfall, 2017. In August 2017, Hurricane Harvey made landfall in Texas as a Category 4 hurricane, bringing with it winds exceeding 130 miles per hour, 215 kilometers per hour. However, it wasn't Harvey's wind speed that would earn it a place in history, it was the storm's unprecedented rainfall. Over the course of 4 days, Harvey stalled over southeastern Texas, dumping more than 60 inches, 1.5 meters, of rain in some areas. This deluge broke records as the highest rainfall total ever recorded for a single storm in the continental United States. The result was catastrophic flooding that submerged entire neighborhoods, turned streets into rivers, and displaced more than 30,000 people. Cities like Houston, the fourth largest city in the US, saw widespread devastation, with thousands of homes and businesses inundated. The economic cost was staggering, with damages estimated at $125 billion, making Harvey one of the costliest natural disasters in US history. The aftermath of Hurricane Harvey revealed the vulnerabilities of urban areas to extreme weather. Poor drainage systems and unchecked urban development exacerbated the flooding, while the prolonged stagnation of the storm raised questions about how climate change might be influencing hurricane behavior. Warmer ocean waters and atmospheric conditions likely fueled the intensity of Harvey, raising alarms about the potential for similar storms in the future. The human toll of Harvey was immense. Dozens lost their lives, and countless others faced the trauma of losing homes and livelihoods. Yet, amid the devastation, stories of resilience and community support emerged. Volunteers formed rescue teams, known as the Cajun Navy, using boats to save stranded residents, while relief organizations worked tirelessly to provide aid. The storm's impact continues to shape discussions about climate resilience and disaster preparedness. The Dust Bowl storms of the 1930s. While hurricanes bring water, the Dust Bowl storms of the 1930s unleashed an equally destructive but entirely different force: dust. Known as black blizzards, these massive storms swept across the US Midwest, transforming fertile farmland into barren wastelands and leaving an indelible mark on the region's history. The Dust Bowl era was triggered by a combination of severe drought and poor agricultural practices. Farmers, eager to cultivate the plains, had plowed up native grasses that anchored the soil. When a prolonged drought struck in the 1930s, the exposed soil was easily carried away by strong winds, creating towering dust storms that choked the air and blocked out the sun. One of the most infamous storms occurred on April 14, 1935, known as Black Sunday. A massive dust storm swept across the Great Plains, with winds reaching up to 60 miles per hour, 97 kilometers per hour. The storm turned day into night, plunging regions like Oklahoma and Kansas into darkness. Dust penetrated homes, schools, and lungs, causing widespread respiratory problems and forcing families to flee their farms in search of better living conditions. The long-term impacts of the Dust Bowl were profound. An estimated 2.5 million people left the plains, many heading to California in what became one of the largest migrations in US history. The crisis also prompted significant changes in agricultural practices and government policy. Programs like the Soil Conservation Service were established to promote sustainable farming techniques, while windbreaks and other erosion control measures became standard. The Dust Bowl storms remain a stark reminder of how human activity can exacerbate natural disasters. Poor land management turned a drought into a catastrophe, reshaping the landscape and livelihoods of an entire region. The lessons of the Dust Bowl are still relevant today, as climate change and land mismanagement threaten to create similar crises in vulnerable areas worldwide. Cyclone Idai, a storm that rewrote records in southern Africa, In March 2019, Cyclone Idai struck southern Africa, becoming one of the deadliest and most destructive storms ever recorded in the region. Making landfall near Beira, Mozambique, Idai brought with it sustained winds of 120 miles per hour, 195 kilometers per hour, torrential rain, and storm surges that inundated coastal areas. The storm's path was highly unusual, looping through the Mozambique Channel and intensifying before returning to land, a trajectory that caught many off guard. The impact of Cyclone Idai was devastating. In Mozambique alone, the storm killed over 600 people, with hundreds more lost across Zimbabwe and Malawi. Floodwaters swallowed entire villages, leaving thousands stranded on rooftops or clinging to trees for survival. Beira, a city of 500,000 people, was nearly obliterated, with 90% of its infrastructure destroyed. Roads, bridges, and communication networks were wiped out, hampering rescue and relief efforts. The aftermath of Idai revealed the vulnerabilities of developing nations to extreme weather. Poor infrastructure and limited resources made it difficult to evacuate residents or provide immediate aid. The flooding also led to secondary disasters, including outbreaks of cholera and malaria, which claimed additional lives in the weeks following the storm. Cyclone Idai's unusual path and intensity sparked discussions about the role of climate change in shaping extreme weather. Warmer ocean temperatures in the Indian Ocean likely contributed to the storm's rapid intensification and persistence. As global temperatures rise, storms like Idai are expected to become more frequent and severe, posing significant challenges for vulnerable regions. Despite the destruction, Cyclone Idai also highlighted the resilience of affected communities. International aid organizations mobilized quickly, providing food, water, and medical supplies to those in need. Local governments and NGOs worked tirelessly to rebuild homes and restore infrastructure, though the road to recovery remains long. A common thread of destruction and Hurricane Harvey, the Dust Bowl storms, and Cyclone Idai are stark examples of how extreme weather can reshape landscapes, communities, and economies. Though vastly different in nature, ranging from torrential rains to windswept dust and cyclonic fury, they share a common thread of destruction and resilience. Each event has forced humanity to confront the power of nature and adapt to its challenges. These storms also underscore the growing need to address the factors that exacerbate such disasters. Whether it's the role of climate change in fueling hurricanes, poor land management intensifying dust storms, or the lack of infrastructure making cyclones more deadly, the interplay between human activity and natural forces is undeniable. As we face a future of increasing weather extremes, the stories of these storms serve as both cautionary tales and calls to action. They remind us of the importance of preparation, sustainable practices, and global cooperation in mitigating the impacts of nature's most destructive forces. While we may never control the weather, we can learn to live alongside it, building resilience and protecting the communities most at risk. Controversial and unexplained weather events, nature's enigma. Some weather events defy not only explanation but also categorization, blurring the lines between meteorology, astronomy, and the unexplored. These phenomena captivate scientists and the public alike, sparking debates and fueling theories. From the devastating Tunguska Event to the eerie darkness of 1780 and the unsettling sounds of sky trumpets and mystery booms, This section delves into some of the most controversial and unexplained weather occurrences in history. The Tunguska Event, 1908, a collision of theories. On the morning of June 30, 1908, a powerful explosion rocked the remote Tunguska region of Siberia, flattening approximately 2,150 square kilometers, 830 square miles, of forest. Witnesses reported seeing a fireball streak across the sky, followed by an ear-splitting explosion and a shockwave that shattered windows and knocked people off their feet hundreds of miles away. Despite the massive destruction, no impact crater was found, leaving scientists to speculate about the event's true nature. The leading theory is that the Tunguska event was caused by an airburst of a meteoroid or comet. As the object entered Earth's atmosphere, it likely disintegrated due to intense heat and pressure, releasing energy equivalent to 10 to 15 megatons of TNT, about 1,000 times more powerful than the atomic bomb dropped on Hiroshima. This theory explains the absence of an impact crater, as the object would have vaporized before hitting the ground. However, alternative theories persist. Some scientists suggest that the explosion could have been caused by a natural gas eruption, with methane released from Siberian permafrost igniting in the atmosphere. Others propose a more exotic explanation, such as a collision with a small black hole or a fragment of antimatter. Though these ideas remain speculative, they highlight the ongoing fascination with this mysterious event. The Tunguska event remains a pivotal example of the power of celestial phenomena to influence Earth's environment. It serves as a stark reminder of the potential hazards posed by near-Earth objects and has inspired efforts to monitor and deflect asteroids that could pose similar threats in the future. The Great Darkness in New England, 1780, day turns to night. On May 19, 1780, residents of New England and parts of Canada experienced a sudden and unexplained darkness that lasted for several hours. Known as the Dark Day, the event began in the morning when the sky turned an ominous yellow, eventually darkening to the point where people required candles to see during the day. Livestock returned to their shelters, and birds stopped singing, creating an eerie silence that added to the unsettling atmosphere. The darkness sparked widespread fear and speculation, with many interpreting it as a divine warning or the end of the world. Religious leaders called for repentance, while scientists of the time struggled to provide a rational explanation. Historical accounts describe an acrid smell in the air, suggesting that the phenomenon might have been caused by smoke or particulates. Modern research supports the theory that the darkness was the result of massive wildfires in the region. Analysis of tree ring data and written records indicates that 1780 was a year of severe drought in North America. Large-scale forest fires would have produced thick smoke, which combined with weather patterns to create the widespread darkness. Additionally, volcanic eruptions have been ruled out as a cause due to a lack of corresponding evidence during that period. Despite these findings, some aspects of the event remain puzzling. The extent and intensity of the darkness were unprecedented, leading some to question whether other atmospheric factors, such as fog or dust storms, played a role. The Great Darkness remains a vivid example of how weather and environmental conditions can produce phenomena that feel almost supernatural. Mystery booms and sky trumpets, sounds from the unknown. Around the world, people have reported hearing mysterious, thunderous booms or trumpet-like sounds emanating from the sky. These auditory anomalies, often heard during weather changes or seismic activity, have sparked scientific investigations and fueled pseudo-scientific theories. Known as sky trumpets and mystery booms, these sounds range from deep rumbles to high-pitched metallic tones, often leaving witnesses baffled. Mystery booms, explosions without explanation. Reports of mystery booms date back centuries but have become more frequent in recent decades, coinciding with advances in communication that allow incidents to be widely shared. These loud, explosive sounds are often heard near coastal areas or fault lines, but they leave no trace, no physical explosion, no seismic activity, and no visible source. One plausible explanation is that these booms are caused by atmospheric phenomena. Changes in air pressure, rapid temperature shifts, or shock waves from distant thunderclaps could create sounds that seem to originate nearby. In coastal regions, Seneca guns is a term used to describe these booms, which may result from underwater seismic activity or collapsing air pockets under the ocean. Some researchers have also linked mystery booms to sonic booms created by aircraft exceeding the speed of sound. However, this theory does not account for instances where no aircraft are reported in the vicinity. Sky trumpets, earthly or extraterrestrial. Sky trumpets, characterized by eerie, metallic sounds, have been reported worldwide, often during periods of atmospheric instability. Videos capturing these sounds frequently go viral, showing skies devoid of any visible source while haunting noises echo in the background. Explanations range from scientific to sensational. From a scientific perspective, sky trumpets could result from natural atmospheric processes. Vibrations caused by shifting air currents, electromagnetic waves, or even auroral activity may produce these sounds. In urban areas, construction equipment or wind passing through structures can also create unusual noises that resonate across long distances. On the pseudo-scientific side, sky trumpets are often linked to conspiracy theories, including secret government experiments, alien communication, or the heralding of apocalyptic events. While such theories lack empirical evidence, they highlight the psychological impact of unexplained phenomena and humanity's tendency to seek meaning in the unknown. A lingering sense of mystery. What ties these events together is their capacity to inspire awe and curiosity. The Tunguska Event challenges our understanding of celestial phenomena and Earth's vulnerabilities. The Great Darkness in New England demonstrates how environmental factors can create seemingly supernatural occurrences. Mystery booms and sky trumpets, meanwhile, remind us that even in an age of advanced science, some aspects of our world remain elusive. These controversial and unexplained weather events encourage us to look beyond the familiar and question the forces that shape our planet. They remind us that despite our technological advancements, nature still holds secrets that intrigue, perplex, and sometimes frighten us. In exploring these mysteries, we not only seek answers but also rediscover the wonder of living on an ever-changing and unpredictable planet. Reflecting on nature's astonishing power, from frogs and fish falling from the sky to snow in the Sahara and fire tornadoes raging through California, the extraordinary weather events we've explored showcase the full spectrum of nature's unpredictability. We've examined the jaw-dropping temperature swings in Montana, the mysterious glow of St. Elmo's fire, and the eerie sounds of sky trumpets that defy easy explanation. These phenomena are not just fascinating, they challenge our understanding of the world around us. We've also ventured into the devastation caused by destructive storms like Hurricane Harvey, the Dust Bowl, and Cyclone Idai, each leaving profound impacts on communities and landscapes. Events like the Tunguska explosion and the Great Darkness of 1780 remind us of nature's power to bewilder and transform, blurring the lines between the meteorological, astronomical, and the unknown. Across centuries and continents, these stories highlight how weather is far more than a backdrop to our lives. It's an active force, capable of shaping history, inspiring awe, and reminding us of the fragile balance of our planet. The power and mystery of nature. Nature is a masterful storyteller, and weather is one of its most dynamic tools. These events, both beautiful and terrifying, teach us humility. They remind us that despite our technological advancements and scientific knowledge, there is still much we don't fully understand. Every unexplained boon, glowing orb, or record-breaking storm is a testament to the complexity of Earth's systems and the interconnectedness of its forces. These phenomena also challenge us to think critically about our relationship with the environment. Are we exacerbating the severity of these events through human activity? How can we better prepare for the unexpected, and how might we adapt to a future where extreme weather could become the norm? Such questions compel us to dig deeper into the science and mysteries of weather. But beyond science, these events inspire wonder. Whether it's the sight of auroras in unexpected skies or the mystery of blood rain, these phenomena spark curiosity, creativity, and a sense of connection to the planet we call home. What weather event shocked you the most? Now, it's your turn to join the conversation. Which of these extraordinary weather events shocked or fascinated you the most? Was it the idea of animals falling from the sky, the destructive beauty of fire tornadoes, or the mystery of ball lightning? Maybe you've witnessed something equally unusual in your own life. If so, we'd love to hear about it. Share your thoughts and stories in the comments. Let's explore together how these events shape not just our understanding of nature but also our place within it. If you enjoyed diving into these incredible phenomena, don't forget to like, share, and subscribe for more explorations of the world's most fascinating mysteries. Nature is full of surprises. Together, let's continue to marvel at its power, uncover its secrets, and appreciate the wonder it brings to our lives.